None of them. This is the ligamentum arteriosum. The ductus is a fetal structure, so we can't see it on this heart. This is what's left of the ductus arteriosus in the adult heart.
Oh,
Okay, so we'll do fetal circulation in a couple of weeks, and then we'll talk about this in more detail.
So in the adult heart, does the fossa ovalis have really much of a purpose?
No, it's just like a scar that's left over from the site where the foramen ovale used to be. It's like if you had a little chicken pox, Mark. That's kind of what it's like inside the heart.
So does the ligamentum arteriosum do anything for us now?
Nope, it's just left over. The site of a former friend, so to speak. Okay, anything on the external list that I didn't cover? Okay, let's go through the vessels really quickly before we move on. We talked about big blue here. That was the pulmonary trunk. And the pulmonary trunk divides into these two vessels, which are the pulmonary arteries, correct. Okay. Now, we also have these blue structures. These are the ones I think that you're going for, Emily. Which one?
Superior vena cava and inferior vena cava.
Good. Okay. So the superior vena cava, they always have longer on the models than the inferior vena cava. I'm not sure why they never give the inferior vena cava a little bit of length, but they never do. Okay. So the superior and inferior vena cava are involved in venous return to the right atrium. Okay, and then the right atrium feeds to the right ventricle. Blood coming out of the right ventricle is going to go into the pulmonary trunk and then into the pulmonary arteries and go to the lungs. Okay, coming back from the lungs, I'm going to have to switch models for a second because I don't have the full number on this one. Okay, coming back from the lungs, we're coming through these four vessels.
coronary vein.
Did you say coronary? Not coronary.
Pulmonary.
Pulmonary. The pulmonary veins. Okay, these four red structures, and that's the typical number. Okay, they will allow blood to enter. What chamber is this?
That's the
Left atrium. Good. The left atrium drains into the left ventricle, and then the outlet for the left ventricle is the aorta. Okay, and the aorta has different sections: ascending, arch, and then descending would be over here. So it's kind of like a candy cane. That's the way I like to describe it to people. Remember how the candy cane has a short section and then the curve and then a long section? That long section would be the descending aorta. Okay? And the descending aorta goes through a couple of different body cavities. It goes through the thoracic and it travels through the diaphragm to go through the abdominal cavity as well. So you'll see later on when we start talking about blood vessel names, we'll have a thoracic section of the descending aorta and an abdominal section, and they use those terms clinically. You might have heard of somebody having an abdominal aortic aneurysm, AAA. So they use those distinctions to say which part of the aorta is affected.
So even though with the pulmonary veins, even though the veins on the model, they're colored red.
Correct. Because if it's a vein, all that means is it's taking blood in which direction with respect to the heart? Toward the heart or away the heart? Towards the heart. If it's an artery, it's taking blood away from the heart. Okay, so right side, deoxygenated blood comes in, deoxygenated blood goes out. Left side, oxygenated blood goes in, oxygenated blood goes out. Okay, so you do have that switch in the colors that you need to be aware of, but the definitions don't change. Those are standard. Okay. All right, what else do we have for internal structures? Valves. We didn't do the valves yet, right?
But-
Correct, I should say?
Yeah, but on the arteries going, the pulmonary
veins. Never mind. I got it.
You figured it out?
Yeah.
Okay.
It's gonna be deoxygenated. And it's going away from the heart.
Pulmonary arteries. Pulmonary veins are coming to the heart. Veins always deliver blood to the heart.
Okay.
Arteries always carry blood away from the heart. So it doesn't matter what the identity of the blood is, whether it's oxygenated or deoxygenated. All that matters is which direction it's moving with respect to the heart.
Okay.
Okay? Does that make sense?
Yes.
Okay. Okay. Let's look at a couple of other internal structures. Don't think I'm going to be able to use this one. We're missing a few valves. I guess I'll go with this one even though it's missing a valve over here. I'll show you on the beef hearts. Okay, so we have 4 valves in the heart. The purpose of the valves is to prevent what?
Backflow.
Backflow of blood. Okay, so they're one-way doors. Okay, so the valve between the right atrium and the right ventricle, which is missing in this model, is the tricuspid valve. Okay, and it's one of the atrioventricular valves. If you're in doubt, the safe answer for a valve between an atrium and a ventricle is atrioventricular valve, and that's a correct answer. Okay, and if it's on the right, it's the right atrioventricular valve. If it's on the left, it's the left atrioventricular valve. The other names for those valves are the tricuspid on the right, and what are the 2 names for the one on the left? Bicuspid or mitral. Okay? Now, those prevent backflow of blood from the ventricle to the atrium when the ventricles contract. Okay? Now, the other 2 valves have this beautiful 3 cup-like structure shape. I don't know if that was a real word string, but I put it together. Okay. And each of those valves is guarding the entrance to one of the great vessels. So the one associated with the blue vessel here will be the pulmonary semilunar valve. The one associated with this big red vessel will be the aortic semilunar valve. Okay? And the semilunar valves open when the ventricles contract to let blood leave the ventricles. They close when the ventricles relax. Caught me spitting on the tape. That's good. It shows I'm human. And they're going to close when the ventricles relax to prevent the blood from refilling the ventricles. Okay?
These are the semilunar valves?
Those are the semilunar valves, correct. Okay, so they'll open when the ventricles contract, close when the ventricles relax.
What would happen to you if the valve didn't work?
You'd have a lot of problems. Your blood would start to accumulate in places where it's not supposed to. Okay, and so yeah, there's different types of valve problems.
Would it would just accumulate, not regurgitate back in? It would just.
It would still accumulate because if it's regurgitating, that means it's backflowing.
Right. Okay.
So it's